here? Okay. All right. So, yell, 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 blah, blah, blah. But here's what we really need to know, and this is where I'm seeing the deficiencies. And there's nothing I can do about it. You got to do something about it yourself. All right. And it's knowing these parent functions, knowing when I have an x squared, that I have a parabola. But then is it, where is it shifted? Is it upside down, skinny, wide? Cubics all look like that, but then they could be flipped and all that other stuff, all the transformations. So what I'm seeing as I continue, let me finish that thought there. Reciprocal function, that's definitely the one with the asymptotes. All right, so 1 over x, we should know that. This is from our book, but I, kind of have the pictures all together here. Oh, I do get sad. People can't graph this. What's the square root of 0? Say it. What's the square root of 1? What's the square root of 4? And then it slowly rises. You can't take square root of negatives in a real coordinate plane. That's why it doesn't exist over there. All right. And then knowing that an exponential, which we made 2 to the x, not e to the x, has that horizontal asymptote at y equals 0 because of raising things to negative powers, like bigger numbers, makes them actually smaller. So small that we get annoyed, we draw a boundary there. All right. Bounded below. Hey, I like that. And then for sure, you should know the absolute value function from v. I mean, an absolute value of v. All right, and then the expectation of picture. Then I say all that, and our first one, we can't freak out though. We can't and then run for the hills because we get all. That's not on our family, kind of thing. Input, say it. So it's telling me I can input -3. Oh no, it's telling me I can't. But I do, and then what kind of dot it is it? Everyone say it. Open. We need a starting point. So we do need that. Otherwise, this little part will be missing if you started just at -4. You're missing an infinite amount of coordinates there from between -4 and -3. So that's the philosophy as well. Why we do plug in -3, but we make it an open dot. -3 plus 4 is 1. 1 to the fourth is 1. -3 comma 1 open. -4 is that nice little coordinate that gets you 0. Okay, what's going on here? Some people stopped, and then this one, there's no way that's linear. That fourth power changes some major stuff. So keep going. One more point shows the turn in direction. -5 plus 4, and then take it to the fourth. A negative times itself 4 times is a positive. All right, so it is like a parabolic. Really, that's true. And we should be able to do that. I mean, I'm sorry. You got to be able to plug in points. I've been saying since August, input, output, and you guys have been sick of hearing it. I don't care. When I get enough people on board to do these really basic ideas of graphing down, and we're already in the middle of September, and it needs to get going. This, through seeing it over and over again, is a horizontal line, but you don't draw it all the way through. All right, you can only draw it from -3 to 3, and that's an open dot. This is a closed dot because of the equal. So hopefully you saw that and had that happen. And then on the right, it's the same as the left with a little different thing here. 3 can be plugged in, and then -1 to the fourth is +1. 4, 0. 5 back to 1. So it is parabolic in nature, and that's true. Blah, 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 blah. Then looking at 8, that is a weird one, but it is part of our family. It is part of our family of functions that we should realize. For instance, the first part, the first family we're dealing with is 1 over x, which I just showed you. We should know that we have a vertical and horizontal asymptote. Interestingly, -4 should not be plugged in, but we will and try to get an open dot. But -4 plus 4 is 0. See, this had a vertical asymptote at x equals 0, but it got moved 4 which direction? Which direction is plus 4 on the inside? 4 what? Left. So actually, I want to graph this asymptote so I can get the shape here. So I can't really draw an open circle because this doesn't evaluate. I can't plug in -4 to get an open dot. It really is the vertical asymptote which controls this graph. Oh, and by the way, less than -4, the graph has a horizontal asymptote controlling it as well. And I'm just going to put it there because that is all I can graph this. I'm not supposed to graph after -4 to the right because of the domain for this piecewise function. And then I can plug in -5. -5 plus 4 is -1. 1 over -1 is -1. I used to have students graph these rationals, and that would just tell you that you're below and to the left here. So the graph must behave to the asymptotes going through that point. That's the point of the asymptotes there. So that's why you see this picture. Ooh, I don't want to cross that asymptote. That's a foul. Next, I have an exponential, and I'll change colors on that. So we got to be able to emulate this on Thursday, man. This is an exponential with no shifting. Wish I would have shifted a little bit, but that's okay. It's our parent function, 2 to the x that I had on our sheet. And I can plug it for the love of dog. What's 2 to the 0 power? 1. How many times have we said that in class here? And he fumbled. I scared him. Anything to the 0 power is 1. These are things that need to be locked in, and I've said it a million times already in here, even though we were supposed to know that as we were coming in. Stop saying that, Mr. Samuelus. All right, so I am going to put 2 in, but what am I going to put for a dot? Say it, 3, 2, 1, go. Okay, let's start it one more time. I am going to put 2 in, but what kind of dot? 3, 2, 1, go. Open. All right, so 2 squared is 4. 1, 2, 3, 4, but it's open. Oh, wait a minute. A horizontal asymptote is something I have for an exponential. So I'm going to put this green horizontal asymptote just from here to here. It's okay. That's why we make it a dotted line. It just helps us form our graph. All right, so just to give myself some perspective here. And it is at y equals 0 because it doesn't go up or down. And then I'm going to plug in -4. Oh, baby. 2 to the -4th power is 1 over 2 to the 4th, which is 1 over 16, which is very, very, very small, which is the point of the asymptote. Why I drew it in the first place, this gets annoying to show how close this gets to 0. And yes, you can put that dot on the vertical asymptote because this is another piece. This is a different piece separate from the other one. So if I were going to say what the domain is still all real numbers because this now is a domain value that I was able to plug in the second piece. All right, and then last but not least, this one. What kind of dot am I supposed to put in? Open or close? 3, 2, 1, go. Close, and it's 2 minus 2, which is 0. 0 squared is 0, so I do get 2, comma 0. Now, this is supposed to be a parabola, but the parabola is moved 2 to the right. So this is what the picture would look like, but I'm only able to do this part because I can only plug in from 2 to infinity. So I can input, output, and I can plug in 3. 3 minus 2 is 1. 1 squared is 1. 4 minus 2 is 2. 2 squared is 1, 2, 3, 4. All right, and then that's it. And here's where you know you have an error. You have an error on these if you don't have a function. Like if this graph you kept going and went over, and then you see this graph above or below this one, you didn't do the piecewise right. You didn't read these and only graph these chunks for these x values. This should always pass the vertical line test. All right, and that's another indication of how you would do this correctly. Okay. Other than that, I'm shutting down the video. We're going to do a review, and you got to come to school for that, but it is online, and you start going through it and look at your notes and try to figure out how to do each part of that.